Good afternoon. Thank you for joining us today for the webcast Decarbonizing Supermarket Refrigeration by Applying Systems Thinking Combining IoT and Machine Learning AI, presented by the Sustainable Development Division. I am Amy Straub, and I will provide technical support for today's webcast. After the presentation, there will be a Q&A session that will be moderated by Dr. Caroline Craigie. Now I will turn it over to Caroline to introduce you to today's presenter, David Reitz.
Thank you, Amy. I am so excited to welcome David Reitz. Thank you so much, David, for agreeing to present today. I heard David speak at the annual conference in May in New Orleans on this topic, and it was such a great talk. I know you all will enjoy it, and I am looking forward to learning more. I'll also give you a brief overview of David's many accomplishments before we get started. So David has his master's in industrial engineering as well as an MBA. He's worked for the DeHaan Group for 10 years as an employee advisor and partner. He leads partnerships and business development for them. He has also served as CEO and subsidiary director at Inventec Performance Chemicals USA, where he led all aspects of the market's operations, including efforts to bring innovative manufacturing products to market. David also spent a decade with Procter & Gamble in multiple senior general management, corporate finance, and marketing positions. And even prior to that, he worked at Cooper Tire as a senior corporate engineer, advising senior management in the US, Mexico, and the UK. So a wealth of experience, lots of knowledge, lots of interesting background. And so very glad to have you presenting for us, David, and looking forward to learning more.
Thank you, Caroline. Hearing all that, it makes me sound pretty old, actually, hearing all the years of work, but I'm super happy to be here to present to the group and as part of the webinar series. So in general, I'll go over the problem and solution of refrigeration in supermarkets, the multiple issues and systems approach, and some details on the technology and results, and just kind of some final thoughts on where this technology and other technologies can go. I wanted to start with the Sustainable Development Division. So I did a presentation for the Sustainable Development Division, and they look at the complex problems that have been defined in the UN Global Goals for Sustainable Development, and they're set up into 17 different goals, and look for research and innovations in these different areas. And so this year, actually, I know for Montreal, there is over 60 different presentations submitted for these different areas. The solution of refrigeration and IoT falls under climate action, the 13th goal for the UN Global Goals for Sustainability. And this climate action, I wanted to talk about this a little bit. We have global CO2 emissions going up, and with that, temperatures rising. And whether it's because of human action or others, been called a climate crisis. The good news, even as these are going up, the amount of CO2 is leveling off because of actions from the last 10 years. So cost of wind energy is down 70%, cost of solar is down 90%, renewables of electricity it makes out 80% of electricity. So the good news about this is that it is high ROI. It's great. It's good for the economy and is a job creator. Solving these goals is also good for business. And as Caroline said, I started in engineering, work in business, and kind of and bridging the gap. So one question I have is, I generally ask is which solution, the wind solution, solar, or, supermarket refrigeration or refrigeration controls, A, B, or C, which one of these can have the most impact? And often, if you don't see the title of a presentation, it can be A or B, but refrigeration is 1,000, 2,000, 3,000, 4,000 times more potent than CO2 for global warming potential for the atmosphere. So there is a group that ranks the different solutions for climate action, and refrigeration, as you can see here, is the #1 solution, ahead of wind turbines, reducing food waste. And in kind of equivalence, it's a 90 billion ton opportunity. So what is the kind of multidimensional problem that takes system thinking? refrigeration is an old industry, so there's this huge install base of refrigeration. There's hundreds of different types of equipment, and the refrigerant is leaking on average in refrigeration systems 25% of this time. So this highly potent global warming potential refrigerant is going into the atmosphere, and it is forecasted to be a contributor to climate change 1 degree Fahrenheit by 2050, unless it's controlled. So there's change to newer systems of natural refrigerants, which are high cost. There's large shortage of technicians, which is challenging for the industry. There's changing regulations, and there's lack of precise information of how the systems actually work. So a mechanical engineer, it came from a mechanical engineer with very much a systems thinking, looked at combining a solution that used computer science and AI, used mechanical engineering, electrical engineering, combined facility management, reporting systems, regulations, and financial analysis, carbon credits, to come up with a system solution to a complex problem. And I wanted to highlight something on artificial intelligence. We're in the solution that the engineer came up with. It was using artificial intelligence, which is a 70-year-old technology, and it's to mimic human behavior. A less 20-year-old technology is machine learning, and then deep learning, which is the AI that we hear about today, is using neural networks to kind of supercharge the ability for computers to mimic human behavior. And by utilizing, it's actually algorithmic learning, kind of in this area, was able to come up with this solution. So the technology is called Matelex technology, and there's several different technologies out there that do something similar to this. Here, we measure at the installation. So we use sensors to measure, do analysis either in the cloud or at the installation, and then present it in an actionable way for optimization and communication. So leak detection, this is the base technology, utilizes sensors, and this represents a refrigerant tank here. So it represents the natural gas law, which there's a lot of engineers on the call. PV equals nRT. The volume in a refrigerant system is always changing based on different parameters. So what the system does, it takes all those parameters, uses AI to, over a 7-day learning period, to learn the volume of the system. And the main issue are leaking these high potent global warming potential refrigerants. And so, and detecting these leaks. So this Matelex solution will learn the volume of the system. And when the volume changes, it will send out an alert. The system also monitors real time, every hour, the energy monitoring every second, and analyzes those data, provides it not only to the end user, but to the facility managers and the maintenance companies that are monitoring the systems. Here's an example of the energy solution, and I can bring up a live version of this. It will offer advice. So in the past, these solutions were, or the systems, you didn't have visibility into the systems. And now you go from no visibility to having visibility. And just to highlight this is like current state, I would say 90% of the US market does not have visibility into refrigerant systems at the supermarket or other commercial installations. And then and I'll show you a live demo here. Here is a demo of a system, and this is just one system, but you can get a map of the total number of installations that you have for your facility. And you can see live the fluid curves, and when there's a leak, you will get a alert, and the alert will allow somebody to come and do maintenance and fix the leak. Here is energy data, which can be used to optimize, and typically we see about 20% savings on energy, and it logs all activity. Currently, you go into systems today in most supermarkets, you don't know if there's a leak or not, and here it's automatically, you're alerted automatically. I'll share some of the results. So the results are, with responsiveness, 80% less use of refrigerants, lowering energy bills by 20%, being more compliant with regulation, with changing regulations today. Leak detection similar to this are going to be mandatory by 2025. And then lastly, the visibility of the system helps to coordinate. Currently, what I see in a lot of systems, there's a temperature gauge in a cooler. And once the temperature is not held at the right level, then they'll call in a maintenance person to come and fix the system. That's a lagging indicator. When we see a leak, that is a leading indicator, because leaks can happen over many, many days, many, many months before there's a temperature issue. And I'll highlight just a couple case studies. Here you have several systems, 6 systems monitored in 4 stores. It was a 6-month study. The refrigerant was 404A, which is almost 4,000 times more potent than CO2. And what this company did is we ran their current system where they would get called in if there was a temperature event versus when we would see a leak. And over here on the right-hand side, you can see we saw the leak on day 1, where the temperature and when technician was called in was day 6. Number of days saved were 5, 25, 103. On average, 60 days, we could tell that there was a leak that would lead to a temperature event. And when there's temperature events, you have other bad issues that can happen with food. We also would be able to save this amount of refrigeration defined by the leak rate that we would see. So about 80%, this is 79% in this study. And currently we replicated this study in New Haven. We're on that now. And here's a second study deployed in 100 markets, a 1-year study. And in this one, the year 1, 28% reduction in the amount of refrigerant used. They had a leak detection in place, which was, it was like a sniffer technology, kind of like a smoke alarm. It would look in the air and look for parts per million, but it was not effective and not as sensitive as this IoT solution. And over a 2-year period, they had 39% savings versus baseline, and they had return on investment less than a year. So we're in 4,000 installations, and doing research now with Yale to also bring in additional data of temperature events and other things to become more predictive at leaks for these systems. I want to talk a little about some other applications. We're looking at, how do we bring in other inspirations to make the design better and improvements on how the Matelex system works. So we're looking at things like UX design, machine learning and neural networks, adding additional sensors, additional capabilities, faster learning periods. So the current period is 7 days. It takes 7 days to learn the volume that's in a system. So we're running now different machine learning type algorithms, connecting IoT nodes for real-time insights, fine-tuning predictions and maintenance schedules, and then additional predictions based on external data. A lot of the data that we're pulling right now, we pulled in 8 different pieces of data points, and then multiple energy data points are all within the installation and in the facility. And now we're looking at how to correlate some outside information that could help us learn and have better insights into the facility. Other application areas, I think if we look back at this UN goals here, looking at problems and solutions that use multi-faceted systems, looking at IoT, AI, within innovation and infrastructure, in many of these areas, clean water and sanitation, there's a lot of application that can happen by kind of utilizing approach by pulling in this multi-diverse solution set. And I would say also for thought, each one of these areas, which are more of the, kind of drill down into the climate area in the UN, is another area for inspiration or areas that can be used to solve with system thinking. And other areas that could be solved with IoT and system thinking, digital twins and enterprise metaverse. This is an emerging area. IoT and security, two that have been developed in the past. Internet of healthcare things in industrial IoT may benefit by drilling down not only to machine learning, but then applying the neural network AI to these systems. And what can be done there, I think it opens up a lot additional solutions. And then there's emerging application in power systems, and then also data utilization. So these are other application areas that it can be applied to. So that in brief is the solution, which is very impactful now in refrigerant management and can be applied more broadly to these other areas. And I think the presentation will be uploaded, but I have my contact information at the end if anybody wanted to contact me.
Thank you, David. So are you ready for some Q&A?
Yeah, yeah, for sure.
Okay, because I'm guessing that our audience probably has a lot of questions because this is really intriguing. One question, just to kind of kick things off as people start to formulate their own questions. I was curious, in general, it seems like there's a lot of really good selling points for this technology and for your approach. You said, if I understood correctly, that 90% of current installations are not doing any proactive monitoring of refrigerant leakages. Did I have that correct?
Yeah, they don't have an alert automatic system in place. Yeah.
And so what's your approach for selling this to potential clients? I mean, is the appeal just the ROI? How do you sell it?
Yeah, that's a great question. One, we're kind of helped by regulation, which is saying that you need to use automatic leak detection. So the amount of searches and amount of people looking for a solution is going up. And two, really is by trying to solve the unique problem that the customer has, because each one of them, they have different types of refrigerant systems. We have great benefits, which and fast ROI, which meets financial, but it's really about listening to the clients or customers and understanding what uniquely they want to solve for. And they see the benefits, they're pretty obvious, but a lot of times it's how do you implement it? How do you bridge it into 100, 200, 1,000 supermarkets that have all different types of installations? And one good point is the technology that Matelex has is it's agnostic to any type of compressor or installation. It can be installed across all any type of installation. So it's a good selling point. But there's still planning, there's budgeting, the basics of figuring out how to roll it out. How do you work with your third-party suppliers that are doing the maintenance? So there's like this whole back-end problem to solve and to support them with and to help with them with to get it into market.
Thank you. So definitely that tailored approach. So cool. So we're getting a load of questions here. So I'll go ahead and I know you could probably see them, David, but I'll go ahead and read them out loud. So we have a question from Zion asking, which types of machine learning algorithms are you using? For example, RNN, LSTM, etc. Could you talk some more about the machine learning and digital twin aspects of your work?
Did I say at the beginning, I'm a master's in industrial engineer, but I'm not computer science or super technical. I'm good at like bringing the parts together. I will have to follow up on that to specifically answer that, which I will. So if that person wants to send me an email directly, I can ask that. So I know the basics of how it works, which it takes in these 8 pieces of data, which includes temperature, pressure, and a volume measurement. And because it's a gas, that volume is constantly changing. So it takes 7 days learning as parameters change what the volume should be. And then once it learns the volume under these different parameters, it can look at the volume going up and down. And when it gets out of balance, that's when it sends an alert. And it does a analysis, and I don't know, what type of analysis, but it's all kind of cloud-based. But if you give me that specific question, because I don't know those terms as well, I can follow up with our tech group and get you a specific answer.
And I would actually like to follow up briefly on something you mentioned as you were responding to this question. Your role as an industrial engineer, as a systems engineer, kind of pulling all these pieces together, the fact that although you are not a computer science, you don't have that computer science background, but you certainly understand the technical aspects of it sufficiently to get all the moving parts to work together. Could you just speak briefly about that? Because I know we have a number of students, industrial engineering students, who are attending the webinar, and just if you could just talk about how your IE background, your systems thinking, your systems knowledge helps you to, succeed in that role.
Yeah, I think the one thing about industrial engineering, so I had an undergrad in civil engineering, I got a master's in industrial engineering, and then the MBA, is that it has allowed me to look at things in a broad way, but also get deep enough in different subjects to bring them in. So for IoT, for example, I don't know the programming language, but I know enough to ask about data security, about how the front end works, how the back end, if we can connect to the intranet cloud within a large client's system. Can we create a cloud solution versus just, that is a digital twin of a mechanical solution? And it just allows me to ask the right questions. And sometimes I get credit for being smarter than I am because I'm just asking because I don't know. But I think that's the key. Industrial engineering training allows me to know that there is all these factors. And I would say some of the factors I learned in industrial engineering that is as important as those others are like the human factor. How are the people going to see this solution, feel about it? How are they going to react? What are the human challenges? And then second, I took, I think it was called engineering economics as an IE. And I tell you what, it is super, super important because ROI, financial return, understanding the mechanics of that, being able to explain that is as important as having a technical solution. So it's asking the right technical questions, and then the human factor, the financial factor, and bringing that together actually enabled me a lot as an industrial engineer, but also manager as well. Does that answer your question?
Absolutely. Thank you so much. And thank you for the shout out to engineering economy. That's the importance of that in education. Cool. Thank you. Let me go ahead with the questions. We're getting a few more rolling in. We did have Scylla asking if you would be willing to show the slide that had the 10 key areas that had the refrigeration listed as refrigeration management as the top solution to climate issues. I would like to see that again as well.
Yeah, absolutely.
Thank you.
These solutions, they're ranked by Project Drawdown. Project Drawdown ranks actually the top 100 climate actions you can take. There's a lot of things that we can do to reduce global warming potential, but they ranked 100 solutions. And actually there's a book out there and you can kind of look through there and read about each one of them. And when they ranked them, I didn't know this. This was like a big surprise to me when I started working on this refrigerant solution. The number one is refrigerant management because it has such high global warming potential. A, B, because there is many leaks, and C, there is actions that you can do that can reduce that. So because of those things, it ranks number one out of 100 different solutions that they've ranked.
Yeah, that was very surprising to me as well the first time when I heard your original presentation in May, and I'm sure that is new knowledge for much of our audience. It's alarming and also interesting. I'd like to also ask, we have an anonymous attendee asking if you would be willing to comment on the current and future dynamic between edge-based and cloud-based solutions in these systems.
I'd have to take that to our technical group, because again, that's a very good question when I would think to ask, but I can share it with them.
John has a question here. You can probably see, in addition to refrigerant loss, many supermarkets have open freezers and refrigerators, open wall, which is convenient for the shopper, but not energy efficient, and that creates additional environmental concerns. Are there any alternatives that would meet supermarket needs in a more sustainable way?
So for those open systems, and I really think you'll see that issue being addressed more and more over the next several years in the US, and they've already started to address John's concern in Europe. So they use like high efficiency systems where they create, you don't lose, the refrigeration and efficiency in their coolers. There is almost nothing if you go to Europe, where right now, if you go up to a supermarket, I was at one today, you go to the yogurt aisle and you can just reach in and grab a yogurt. There's really much of Europe, Western Europe, everything will either be behind amount of plastic or some other barrier, and it even could be a drawer or other things. So I think they're figuring out more mechanical solutions for that issue. I do think so. One thing with Matelex, it developed in Europe first, and I think Europe does have a leading tendency for safety, environment, that we can take inspiration from. And also, again, I'm like on the business side, I'd love to try to bring the bridge of bringing those technologies to the US, or develop that type of thinking in the US.
Awesome, thank you. So we have Steve asking, as older refrigerant systems become obsolete and they require replacement, do you see newer systems becoming available that actually come with this type of monitoring analysis capabilities, where that's just the standard? It seems like in time this would become seamless to the user rather than kind of this extra thing.
Yeah, that's a good question, Steve. So there is a company called Hussmann that's now building into their compressors leak detection, and into their and many of the controls companies are coming up with solutions, and it's an emerging technology on the automatic leak detection side. Newer systems are, and then some of the newer systems that are interesting for refrigeration are systems that have very, very low global warming potential. So CO2, which is a 1-for-1 molecule, versus the HFCs, which is the current refrigerant technology, which is, like I said, 1,000, 2,000, 3,000, 4,000 to 1. CO2 systems have been adopted widely in Europe. And this is interesting. So the amount of global warming potential is greatly reduced. It is reduced, to a very, very low level. But CO2 systems are a high energy system because they're high pressure system. To get the amount of cold that you need, you have to have high pressure. High pressure uses more energy. So if you're getting energy from fossil fuels, you can offset the gains that you have in the refrigerant with that. Also, bring a high pressure system, if there's a leak in that system, you lose the entire charge very quickly, and you have to have maintenance, and you could lose product. So there's also these new systems, and I think CO2, I see more and more of those being installed. It's still very small install base in the US. I think in California, if I'm not mistaken, the CARB laws there say the new systems need to be CO2 based. for supermarkets because they're really trying to reduce the amount of leaks, and some of those do have leak detection on them as well. So I think there's new technologies, and then there's newer systems with some of the older refrigerants that are using these solutions.
Yeah, that is a great question. We have a question from Angel asking, what are the main roadblocks or challenges in implementing these types of systems?
I think along with a lot of newer technologies, there is a trying to do what you understand and do what you know, and learning can be a significant barrier, and looking at something new as a risk is a barrier rather than an opportunity. And so I think education is a huge part of bringing new technology to market. We do that actually. We put out papers, we go and do different presentations, and then we meet closely. The second thing that's still, it's a barrier, but it's something interesting, and a lot of engineers and a lot of people on this call would kind of geek out and love to do it, is that it's like really complex systems. Like we're working with a client with like 2,000 different stores. Each one of them will have 1 to 4 different installations. So there might be up to 9,000 installations, and how to solve that, they really have to look at the age, they have to look at the technologies, they have to look at it as a multidimensional problem and break it apart and figure out what is the best solution for the different parts. So I think that is a key barrier. And then the last thing, which I mentioned previously, is budgets. Like the new technology, having something new is incremental budgets, and so figuring that out is challenging. Well, the other barrier that is culture. So for example, for supermarkets, they run on small margins. They're managed a lot of times in different regions, and a region president is trying to get food on the shelf, the best quality, and doesn't really understand refrigeration. And you say, okay, you want to try new refrigeration? They'll say, well, are we compliant with what we need to do refrigeration? Or do we have, if we're compliant, you don't want to spend the budget or the time on that. So can be a cultural shift to really think about it as innovation, thinking about it as what is the opportunity. So those are a few of the barriers, but they're the challenges, and they're interesting to try to understand, because I believe in this technology. I see it, it's impactful. We just finished a study. It was a 400 kilo system, and it was a blind study. We started monitoring it. We saw a leak start in June. We just closed the study. The temperature hadn't changed yet, but they lost 100 kilos of refrigerant. Now we saw it leaking, this entire summer, and it was part of the study to prove that it worked from an ROI basis and everything. Being able to show that and demonstrate that, I think, can help to alleviate some of the barriers.
That's an awesome example. We have 2 kind of related questions, one from John and one from Glenn. So Glenn is asking very generally, why is the US market lagging on these issues compared to Europe? And then John more specifically is saying, what is there about the rules of the capitalist economy in Europe relative to the economic system in the US that causes European businesses to be ahead of the US in dealing with these issues? Basically, why are we behind them?
That is super interesting. I don't know if I know the root of it, if it's part of the cultural roots but what I can see is under the regulations that I see that Europe is ahead in has to do with safety, consumer protection, the environment, digital security. And all of these, the European Union is a leader. Waste reduction. I just saw about a month ago, Apple is changing its little connector cord to be this I think it's called, I don't know, their fast cord, which they were trying not to do for years and years, because the European Union said that it's not going to, they will not allow this cord. They want a universal cord so that there's not as much e-waste. And now Apple, this big company, now has changed and will offer the universal, which is very different for Apple. So I don't know the historical reasons why on safety. There's, you think about all the Black Plagues and all the issues of health that have started in Europe, and I think, well, maybe they're just a little bit more safety conscious because of being in close proximity and whatnot. But I don't know the root causes. I just see that they lead, and then we take a little bit more time, but we eventually follow.
Very interesting points. Glenn also asks, and I think you mentioned this statistic in your talk, if I remember correctly. He said, I've heard that the industry leak rate is close to 25%. Is that true? And if so, how sustainable is it?
Yeah, very good question. The 25% is it's the general rate that is quoted and that has been seen in studies. And the interesting thing, that's 25% we've seen in the US, and we've also seen in Europe. And the second part is it sustainable? It's not sustainable for a couple reasons. One, we would be continuing to leak, and the amount of demand and the growing amount of commercial refrigeration, it would be looking at the chart of CO2, we would just be contributing more and more CO2 to the atmosphere. The R squared value, the correlation between that CO2 chart and the global change in temperature is 80%. So that is highly correlated. So from a climate change perspective, it's not sustainable. And then second, there is the price of HFCs, which are these refrigerants that are being leaked, is by the laws of supply and demand is increasing and will continue to increase. So financially, it won't be sustainable because it happened in Europe. They pulled back the supply side. They regulated back how much supply could be in the market, and the cost went up. The same is happening in Europe, in the US in 2024, starting in January. They're lowering the amount that can be sold in the US by 40% versus a baseline of 4 years ago. So even as demand's going up, the government's pulling back supply. So unless you contain it in the systems, you'll be paying more and more by the laws of supply and demand. The same thing happened in Europe, and prices went up by 10, 15 times the amount. So what would be $10,000 to fill a medium system in here in the US would be over $100,000 and could literally put a small grocer out of business. So financially, it won't be sustainable. Globally, it's not sustainable. So it really needs to be dealt with. And the good news is, if you have this detection, if you have good maintenance practices, you have good systems in place, good management in place, the leak rates can go from 25% to under 5%. And that's what we see best of class with our clients, is under 5%.
I'd like to ask a quick follow-up question on that, because that was really interesting. So you mentioned, it looks like the cost of HFCs for supermarkets likely to rise significantly, and small businesses being, likely to potentially heavily impacted by that. Do you see small to medium-sized enterprises as being, are they actually potential clients for your technology? I know larger, chain groceries can probably afford this type of monitoring and assessment, but a small grocer, how reachable is that for them?
Because of the fast ROI on it, it is really important for the small and medium grocers. So the one challenge with regulations, and I see it with this regulation, I've seen it with others, is it can benefit the biggest actors in an industry because they can afford the regulation. The small and medium companies sometimes are not on top of it. They lag behind having action. So the interesting thing, this technology is kind of like cell phones, where there is a lot of investment bigger companies have done in trying to put that the 10% that's online. You mentioned like 90% is offline. 10% are the big actors. They've got things online. Maybe not as detailed or clear, but they have a system in place. And what a system like Matelex can do is take a small company and take it from kind of not having cell service to having, an Apple phone overnight, or not, not having a phone where they can see their energy online, they can see their leaks online, they can manage their refrigerant maintenance online. It can help equalize. I think the challenge is the bigger companies know about it. They've been tracking it. They've got lobbyists. They're trying to figure it out. And it'll be a surprise. It'll be more of like, wow, my bill just went up, and how do I handle it?
That sounds hopeful. We also have a comment from our anonymous attendee that even though we are lagging now, the US will catch up. US is a pioneer in this area. We have more intellectual manpower here, especially with the rise of China. This will only make the US accelerate this process. Do you agree with that, David?
Well, as a red-blooded American, for sure. Like I grew up in the Midwest, and I believe we can, we've got the manpower, and we've got greatest universities, we've got really smart business people. And so, yeah, I do believe that. And we do see that. We see some investment in this area, this particular area, IoT refrigeration. We see U.S. companies now, putting their people and, most importantly, and money behind it.
I agree with that. Could I ask one more very quick question? Again, since I know we do have some industrial engineering students attending this presentation, David has this wealth of experience, and he has both a master's in industrial engineering and an MBA. A question I often get from students is, after my bachelor's, is it a good idea to go on for a master's in IE, or should I go for my MBA, or should I work for a while first? Do you have just any words of wisdom on that topic?
I mean, my words of wisdom is it depends. It really depends on the individual, what their aspirations are, what their opportunities are. I did the MBA, and I took time to work for several years before going to the MBA. And that was great because a lot of the fellow students did the same. And so we brought our work experience with us as part of what we brought to the MBA program. I think it's what I would say is those are all really good options. Talk to your mentors, talk to your family, talk to your friends, and then I heard this thing, it's called gut data gut, and I do this in business. You might have an idea, you want to go in a direction, so then you go ask these people, you get in data, you do some research. At the end of the day, you make a gut decision of what you want to do, and you move in that direction. So, and there's so many paths. The one thing I'd say with IE, you've got the world is in front of you, because you can do so many things with an IE degree. You're not pigeonholed. You can be an analyst, you can be a consultant, you can be a business owner, you could be so many things. So, but figure out what works for you and what will make you happy, and go for it.
Awesome advice. Thank you. And thank you for a wonderful presentation. Very educational. Thank you for answering all these good questions. Really appreciate your time.
Well, thanks for having me. I really appreciate it.